Body planes. The body can be divided in different axes depending on what you're looking for. The first one is known as the sagittal plane. The sagittal plane is going to separate right and left sides. You have infinite amounts of sagittal cuts because as long as there's a right portion and a left portion, doesn't matter if it's the middle, offset, either way, they're all referred to as sagittal planes. But if you go right down the very midline, that's referred to as mid-sagittal. Now, mid-sagittal is equal right and left halves. There is another term called median that also is the same thing. So mid-sagittal or median. Personally, I like mid-sagittal. You're not going to mix up the spelling. But median and medial, that one letter, the N versus the L, has a whole different meaning. Median is the midline. Medial is the directional term meaning towards the middle. So if you're being asked for what's the midline and you say medial, unfortunately that's the wrong thing because it's heading towards the middle. Mid-sagittal, that one is not going to be mixed up with median or medial. So sagittal cuts, sagittal plane, right and left. Mid-sagittal is the dead middle one. So that's looking at right and left. The next is frontal or coronal. In the case of the frontal or coronal plane, you're looking at a cut that will be separating front or anterior and back or posterior. Again, there's infinite amounts of cuts as long as there's a front and back portion. So frontal or coronal. Which brings us up to transverse or horizontal. In the case of transverse, it's going through creating a top and bottom, or a superior and inferior portion. Just like the previous two, you have infinite amounts of cuts because all you're doing is making sure there's a top and bottom portion. So the idea of transverse or horizontal. Now all these are at perfect 90-degree angles to each other. If you're offset, that's something completely different. So exact 90-degree angles to each other, that is what we're looking at for these three planes. When you're offset, that's called an oblique cut. So if you're coming instead of midline, you went a little bit angled and came down an angle, that's an oblique cut. Doesn't matter if it's anywhere between the 1 degree and 89 degrees, that's oblique. The perfect flat 0 and then 90 degrees, that is when we look at the three different planes. So we look at the examples here. Again, you can see frontal, separating front and back. You then have the idea of mid-sagittal or sagittal, and then you have transverse. Here's an image. You're looking at this. This is going to be a mid-sagittal cut. Actually, sorry, not mid-sagittal, it's a sagittal cut. It's a little offset. You can see by the yellow line in the picture. But the reason it's important to understand these different planes is depending on where the view is, which sagittal plane or which frontal plane or which transverse plane, you know what should be located at that location. So when you're trying to have this imaging occur, it gives medical professionals an idea of what should be there versus what might not be there if something's missing. Same thing for this cut. This is now going to be a frontal or coronal cut. You can see how you're looking at the vertebrae. You're going to see the kidneys in there. You can see actually parts of the head of the femur and the coxal bone. So looking at all these different parts and pieces, knowing what should be at that plane, and is that normal or abnormal? So it's helping to identify where things are located. Body cavities. Now, body cavities, there are two main body cavities, dorsal and ventral. Now, as you can notice, the dorsal body cavity is made up of the cranial cavity as well as the vertebral cavity. So both the cranial and vertebral cavities comprise the dorsal cavity. The cranial cavity houses the brain. The vertebral cavity is what's going to house the actual spinal cord. Now, on the lateral view, I circled those, but if you look at the anterior view, you can still see the cranial cavity and the vertebral cavity there. But notice the vertebral cavity is going to dive down behind or posterior to the actual ventral body cavity. Hence why it's called dorsal body cavity. Now, if we move along, and try to get rid of that, you'll notice the ventral body cavity. That's the thing that's there in purple and blue and orange and pink and green. All that together is the ventral body cavity. This whole massive area. Now, the ventral body cavity actually comprises several other cavities inside of it. You have the thoracic cavity, which you can notice the thoracic cavity is from the diaphragm up. So this is the thoracic cavity. From the thoracic cavity then, you have the abdominal pelvic cavity, what goes below, abdominal pelvic cavity. But inside of the thoracic as well as the abdominal pelvic will be other smaller cavities. Let's start with the thoracic cavity. In the thoracic cavity, you're going to have the mediastinum. That's the one in orange right in the middle. That's that open space above or superior to the heart. That's the mediastinum cavity. You then have the two pleural cavities. Pleural cavities are the ones in purple. The pleural cavities are what house the lungs. And then we have the heart, which is the pericardial cavity. So the heart is housed in the pericardial cavity. So all those cavities, mediastinum, both pleural as well as pericardial, are all housed within the thoracic cavity. The abdominal pelvic cavity, which is lower, below, or inferior to the diaphragm, that's going to have the abdominal cavity, which has things like your liver, your stomach, your small intestines, your large intestines. Then you also have below that, or inferior to that, will be the pelvic cavity. The pelvic cavity houses more of the reproductive organs or the urinary bladder there. So both the pelvic and abdominal cavities are going to be found within the abdominal pelvic cavity. Which means your entire body is this whole nestled system. If you take the ventral body cavity, the whole front, go a little more precise, a little more specific inside, you get the thoracic and then the abdominal pelvic cavities. Go in the thoracic, you have the mediastinum, pericardium, and the two pleural cavities. Inside the abdominal pelvic cavity is the abdominal, and then below that is the pelvic region, the pelvic cavity. So again, your body's being organized by having compartments within compartments within compartments. And in those compartments, some of them are going to have this parietal and visceral serosa membrane. The parietal serosa is going to be a membrane that lines the outside parts in the cavity. So in the case of, let's say, the pleural cavity, where the lungs are, you have the actual lung, then you have the ribs around it. The parietal serosa is going to be lining the inside of that rib cage, while the visceral serosa would be like saran wrap covering tight over the lungs. These two membranes create a little space in between, and that space can be filled with serous fluid. The question is why? Well, think about it. Your lungs are constantly moving. Your heart's constantly moving. For that matter, most of your GI tract is moving around. You want to reduce friction. The serous membrane system, this parietal visceral membrane, is going to help reduce friction, creating an almost frictionless environment. So think of it like this. If you put your hand to a balloon, the part of the balloon that is touching the hand, so this area right here, that would be the visceral serosa, touch the organ. While the part out here, that would be touching the cavity walls, that would be the actual parietal serosa. And the part in between is where the fluid would be found. So you have, for example, the heart here. You can see the heart has the visceral pericardium, is what's tight right around the heart. With the serous fluid is in between, there's still a serous fluid in between, and the parietal pericardium is what's found covering the outside there, will be touching the actual cavity membrane. So we're creating this double membrane system, this system that allows the heart to beat in a basically frictionless environment. Oh, that's right, one thing to mention. It's not visceral serosa anymore, it's visceral pericardium. And just like it's not parietal serosa, it's parietal pericardium. The name tells you location. So visceral pericardium tells you it's tight to the heart. Parietal pericardium tells you it's lining the cavity around the heart. So the lungs here, visceral pleura, then parietal pleura, pleura for lungs. So if you look in the blown up image here, you're going to have the visceral pleura is lining tight to the lungs, so it's right here, tight to the lungs. And then parietal pleura is a little further out. The serous is what's in between, the serous fluid. So again, that membrane system is all about trying to create a frictionless environment. Visceral, in this case, lungs pleura. So visceral pleura is going to be tight to the lungs. Parietal pleura will be what's lining the cage where the ribs are. Serous fluid in between. Going down into the abdominal cavity, we then end up having all those abdominal organs, the small intestines, large intestines, stomach, liver. They're still covered by a membrane as well, visceral parietal system. But it's a little different here because there's more than one organ. So in this case, the parietal peritoneum, is going to line the entire outside of the cavity. So it goes around the outside of the actual abdominal wall. Well then, if we switch over and look at the visceral peritoneum, you'll notice the visceral peritoneum is what's going around each individual organ, covering and coating those organs, which means the intestines and all those parts have like saran wrap around them. That's the visceral peritoneum. Peritoneum referring to the abdominal cavity, so peritoneum, and it's helping to, again, create a frictionless environment. Now, if you're thinking, hold on, the heart's constantly beating, lungs constantly breathing. What do my intestines do? Your intestines are having food and waste products moving through them. That's where your digestion occurs. It's constantly moving. Particles through that tubing. Plus, if you bend, if you move, if you angle, as you move your body, those organs are shifting inside. You want to create that roughly frictionless environment again. The abdominopelvic quadrants aren't the most useful. We'll get to one in a second that's more useful. But just be aware the idea of left upper, left lower, right lower quadrant. Now that's more simplistic. The little more complex one is the 9 abdominopelvic regions. These are a little more precise because they break things down to a little bit better area. Let's start with the umbilical region. Think umbilical cord, umbilical region, belly button. That's your umbilical region. If you move just above that or superior to that, you're going to see the epigastric region. EPI, epi, meaning above. So above the gastric, you're towards the top of your gastric region. Moving down below, you head down below the umbilical region. That's the hypogastric region. Hypo, H-Y-P-O, means below or under. Hypogastric, below or bottom of the gastric region. If we move over then, we see the left iliac region and the right iliac region. One of the things to keep in mind, the siding, right and left, is based on the anatomical model or the picture. So if you're looking at it, it looks reversed to you unless you turn your back to match. Like this is my right side. So this would be the right iliac region. But if you're looking at it, if I was facing you, that would look like the left side. That'd be your left facing me. So make sure it's always the naming of the actual model or image you're based on. Right iliac, left iliac. Iliac because the part of the hip you feel is referred to as the iliac crest. Moving up, you then have the left and right lumbar regions. Lumbar is based on the fact that the lumbar vertebrae would wrap around, and that's where would be the lumbar regions. And then the top is the left and right hypochondriac regions. The left and right hypochondriac regions. Hypo meaning below, chondria is cartilage. You're below the cartilage of the ribs. Hypochondriac region. 9 abdominopelvic regions. Besides the names, make sure you know at least one organ in each one of them. If you're looking at the epigastric region, you see the liver's there, the stomach's there. If you're looking at the left hypochondriac region, you've got stomach. Right hypochondriac, liver. The other ones, a lot of them have intestines, so take a look and see what you have there. Small versus large intestines. So the 9 abdominopelvic regions. So why does this matter again? Well, again, because we're building the foundation of anatomy. The foundation of the terminology you'll use in future chapters, as well as the entire course as we talk about other body systems. So learning it now, building the foundation, to hopefully help make things easier in the future.